this entire PowerPoint? I don't know, but we'll get to however far we can get to. But I don't see me going too far into Friday's lesson. So let's say maybe a functions quiz on Friday. Quiz on Friday.
That sounds like a football event.
It's a must.
Do we have?
Function quiz Friday.
We'll see how it goes. Okay. We're going to review the entire functions section. Not every function right now, we're just in general functions. And let's start off. What is a relation? Who remembers what a relation is? Don't go one time.
I feel like it's something really simple that we would all know, but we just don't know it's called a relation.
Okay.
Does it have to do with probability?
No.
No, not probability.
Is it?
Huh? It is a set of ordered pairs. Yes, that is what a relation is. Okay, so like 1, 2, 2, 3, 4, 5, so on and so forth. That is a relation. Okay. Next one's a little bit easier though. Domain. What is domain? All the
coordinates.
all the x's, all the x coordinates. The range is
All the Y's.
all the y's. Yes, you guys remember that one? Good stuff. Good stuff. What about function? What is a function?
It's a line.
It's a relationship.
A line is a function. Yes. It's a relationship between x and y. Okay.
It can only be one main function. And x can only have one y.
And x can only have one y, one input for every output. So yes, one x for every y is a relation where every x is equal to y. And how do you determine if a relation is a function?
Can't have multiple
Yes.
The line
Do
test.
the line test.
Which line test?
The vertical.
The vertical line test. Very good. The vertical line test. So basically a vertical line is drawn and will not intersect the graph more than once. Okay? Start off a little rocky. That's okay, but you got into it. You remembered. Good stuff, good stuff. Second for those who are right. Okay. Oh, okay, not yet, sorry, one more. Okay, do not forget about these. Okay, interval notation and set notation. Those are the two different ways that you can represent domain and range. You guys remember this?
Yes.
Yeah.
I hope so. When do you use the parentheses in interval notation?
When they're not closed.
When it's not, what do you mean not closed?
When it's
It's not an equal sign. It's like greater than equal.
When it's not a greater than or equal to or less than or equal to. So just the less than or just the greater than, right. So in other words, that point is basically not included, okay, a part of that domain or range. And then the brackets,
when the point isn't included.
when it is included, okay? And then there's set notation, okay? It's read as the set of x values such that x is less than 6, as an example, okay? That's the curly brackets, all right? Hope you guys haven't forgot about that. For Trevor and AJ, have y'all seen that before? You use the colon? Okay. So either the bar or the colon is acceptable, okay? But it means the same thing, okay? It means the same thing. The little flip version of looking at sometimes they use the line, sometimes they use the colon. Whiteboards. Okay. I want you to write down the domain and range of this. Let's do interval notation this time, okay? Interval notation. Give you 45. The reason why this is a tricky one. Why? Why is this a little tricky? Awesome.
It's not big, that keeps on going.
Technically, what you have on your board,
The graph represents that, but it keep on going.
it could. How would you know if it kept on going?
Oh, they show arrows.
Arrows. There are no arrows here, so it stops. So it's a little bit tricky. Had it included arrows, then a lot of you guys have been right. It would have been negative infinity to infinity. If If this was a normal, what function? What kind of function is this?
Quadratic.
Quadratic. It's a shape of parabola. It's a quadratic function, and normally quadratics are negative infinity to infinity. However, we don't have no arrowheads here. So the range is from 2 to 10. Okay.
And domain is the
Okay, from 2 to 10, and then the domain is what? Roughly -3 to 3. Now I have a question though. Do I have parentheses, brackets? What? What do I have?
Brackets on two.
Two is a bracket.
2 is a bracket.
And 10 is a bracket.
What about 3 and 3?
bracket.
No, they're parentheses, because they're not part of it.
They are not part of it.
Oh.
They're bounded in between those two. It does not end exactly at 3 and -3. Okay? So those are not included. Very good. Alright, let's look at the next one. Clear your boards. Remember, you give me domain and range for both. Interval notation. If these were connected, then yes, what you guys had on your paper or on your boards is correct. But they're not connected. They're just points. They are literally just 1, 5, 3, 5, 4, 2, and 6, -2. Your domains is what? 1, 3, 4, and 6, and your range is, okay, let's try that again. Your range is what? Your range is what?
5.
-2, 2, and 5. Like literally, you just list them out. When they're points, you list them out. If there was a line connecting all those points, then yes, the domain would be from 1 to 6, and the range would be from -2 to 5. So be careful. Okay? You think they were going over this? Yes. Now I think the next one is it. Should be good. Should be good. Here we go. And I'll have here. We'll do this too. There we go. All right. Let's go. Let's go interval one more time, then we'll do set for the next one. Okay? So let's go 30 seconds. All right. I know you guys have parentheses around your infinities, which is good because infinity is not defined, but for your domain and for your range, your domain, you guys had -4 to infinity. What's around the -4? A bracket, and you guys had 0 to infinity. What's around the 0? Why is there a bracket for both of those?
There's a point at that point.
It's a point. It is defined at that particular point. -4, 0. So I should have a bracket around both. Bracket around both. Okay? I think this is the last one. Yes, it is. It's the last one. I want you guys to do this one in set notation, okay? And just to help you guys out, remember set notation has the curly brackets. It has whatever variable you're doing, whether it's domain or range. You have your colon, and then you have the rest of your expression, okay? So you're doing the domain and range in set notation for the following, okay? Give you guys a minute for this one. We'll add arrows just to make this. Sorry, put these off in the internet so real quick. So we know we have X and Y here, those respective domains and ranges, and because on your X's it's not defined at 2, and for your Y's it's not defined at 0, those will be your set notations. Okay? Questions on notation? Alright, you can erase your boards, you can cap your markers. Let's go back to your paper and pencil. I'll do some more function stuff. What does that mean? It means f of x is also it means function. Right? What is this? The second one. As f of g of x, which means what? You plug g into f, also known as a composite function. Yep, this is a composite function where g goes into f same thing as the notation above it. This is just another way to represent f of g of x, and you go in that order, okay? So g is the inside function that goes in to f.
Solid, you add,
Say again.
solid, you add them together.
You saying it goes like this, then you multiply. This is very, yep, a little bit different. This is multiplication. Now, you add together, you add this in there. That's what you would add.
Without this, you can say f of x plus q.
Exactly, yep, same thing. Same thing as saying f of x plus q of x. Good?
We can also do it the other way.
With minus? Yep. So this is f of x.
But I was talking about actually like if x was actually a number, you could actually do it separately. F first, then
In these cases, yes. In this case, if x was a number, then you would want to plug that number into g, and then that answer you got, you plug it into f.
no, you play it first.
Like you do the composite first and then plug the number in? Yes, you could also do it that way. Like do the composite first and plug the number in, you do the same thing. Okay? Let's practice that. Yeah, let's do whiteboards. And then if you want to like transfer it into your notes, you can. Let's do it on whiteboard. Okay? Let's do the first example. Okay? 46 for the first example. And then we'll erase and then we'll do the second example, okay? It is 19 over 4. Be very, very careful, okay? I like how you guys, most of you all, showed your work, because you cannot forget about what? Those method points, okay? You get method points are when, like, you actually show the plugging in process. Because heaven forbid you say 1 minus 2 and get a negative 1 in the denominator, or something like that, or 6 minus 2, you get, you know, something can happen, something goes wrong. You still can get a method point by plugging in the correct number, showing the grader that you know you're supposed to plug in. So yes, 19 over 4. Let's do the second one. Clear your boards. Do the second one. This means that what? What?
Put F and
Yeah,
G.
What?
it is in the-
That's actually in the G.
I plug f into g. So 5 minus 3x, those inward x's, you square it, and then you add 4. Please tell me you did not put 25 plus 9x squared. No, you gotta do what to this? Foil it, okay? So you gotta write it twice and foil it. And when you actually foil it, you get 25 minus 30x plus a 9x squared plus 4. Then what do? Add like terms, and then it will always be nice to put it into standard form. So you have 9x squared minus 30x plus 29. There you go. So I got that. Okay? So do not forget, that means FOIL. Coming back? Yeah? Good stuff. Okay. Here we go. Turn them off. Or do you want some time to transfer, or you guys good? We got one more. Do this one into your notes. These are exam style questions, wording and everything. And maybe not. We are running out of time a little bit. Do these in your notes. Do these in your notes.